Hi student, in this video we are going to see acceleration and equation of motion questions. Let us first understand what is acceleration. So acceleration is defined as the rate of change of velocity of an object with respect to time. In simple term, when an object speeds up, slows down or changes direction, it is accelerating. Its formula is A equals to V minus U divided by T, where U is initial velocity, V is final velocity and T is time taken. Acceleration is a vector quantity. It has both magnitude as well as direction. Page number 77 in text question. When you will say a body is in uniform acceleration and second part is non-uniform acceleration. So first part, uniform acceleration. An object is said to be in uniform acceleration if its velocity changes by equal amount in equal interval of time, no matter how small the time intervals are. For example, a freely falling object under gravity accelerates uniformly at 9.8 meter per second square. Second part of the question, non-uniform acceleration. An object is said to be in non-uniform acceleration if its velocity changes by unequal amount in equal intervals of time. For example, a car moving through a traffic where the speed increases or decreases irregularly. Page number 77, question number 2. A bus decreases its speed from 80 km per hour to 60 km per hour in 5 seconds. Find the acceleration of the bus. Here initial velocity is 80 km per hour, final velocity is 60 km per hour and time is 5 seconds. Velocities are in kilometer per hour, so first convert that into meter per second. Now 80 kilometers per hour, so 1 kilometer is 1000 meters, so multiply by 1000. Now 1 hour is 60 into 60, that is 3600 seconds. So divide, because R is in denominator, so divide by 60 into 60. So after simplification, you will get 5 by 18. So 80 into 5 by 18. So whenever you want to convert kilometers per hour to meter per second, just multiply by 5 by 18. Now here we can cut it with 2. 2 9s are 18, 240. So we'll get 200 by 9 meter per second. So whenever you want to convert kilometer per hour to meter per second, just multiply by 5 by 18. Now here also 60 kilometers per hour, multiply by 5 by 18. Now cut it with 2. So I am not cutting further, 30 and 9 will go, but I am not cutting further because initial velocity already has 9 in denominator, so it will make my calculation easy. So leave here only 150 by 9 meter per second. Now acceleration is V minus U by T. Now V and U both are in fractions, so write like this, V minus U divided by T. This will make your calculation easy. So it is 150 by 9 minus 200 by 9 in bracket divided by time, that is 5. So that is minus 50 by 9 divided by 5. Now divide, you can change to multiply and take reciprocal of 5. 5 is same as 5 by 1, so into 1 by 5. Cut it, you will get minus 10 by 9, which is minus 1.1 meter per second square. Why negative? Because velocity is decreasing. Next one, a train starting from railway station and moving with uniform acceleration attains a speed of 40 kilometers per hour in 10 minutes. Find its acceleration. Now here a train starting from railway station means initial velocity is 0. Attains a speed of 40 kilometers per hour in 10 minutes. So final velocity is 40 kilometers per hour and time is 10 minutes. We need to find acceleration. SI unit of acceleration is meter per second square. Therefore, when we are calculating acceleration, we convert velocities in meter per second and time in second. Here we need to convert final velocity in meter per second and time from minute to second. Now initial velocity is 0 meter per second, final velocity is 40 kilometers per hour, so multiply by 5 by 18 to convert that into meter per second. Cut with 2 9s are 2, 20 are 40. So we'll get 20 into 5, 100 by 9 meter per second. That is final velocity. Now we have time in minutes. Time is 10 minutes. Minutes to second multiply by 60. So we'll get 600 seconds. Now acceleration is v minus u by t. Now in this case, this final velocity is in fractions. So again we'll write like this only, v minus u divided by t. V is 100 by 9 minus 0 divided by 600. Now 100 by 9 divided by 600, so that is equal to 100 by 9. Convert that into multiplication and take reciprocal of 600. So 600 by 1 will become 1 by 600. So that is equal to 1 by 54. 9 into 6, 54. 1 upon 54 meter per second square is the answer. In text question, page number 81, what is the nature of the distance time graph for uniform and non-uniform motion? Nature of graph is straight line with constant positive slope. Graph characteristics, line is straight and slanted, not horizontal. The steeper the line, the higher is the speed. The slope of the line gives the speed of the object. Next question, what can you say about the motion of an object whose distance time graph is a straight line parallel to x-axis? Answer is object is stationary. Let us understand with an example. Suppose car is parked at 10 meter from you and you are told to write distance of car from you after every 10 second. So when it is 0 second, distance of car from you is 10 meter. After 10 second, it will remain 10 meter. After 20 second, it will be at 10 meter as car is stationary. So whatever be the time, car position from you will remain same. When we plot this data on distance time graph, as distance is same for any time interval, we'll get straight line parallel to time axis. Therefore, answer for this question is object is stationary or it is at rest. Next question, what can you say about the motion of an object if its speed time graph is straight line parallel to time axis? To understand this question, let us take speed time graph where graph is straight line parallel to time axis. Now from graph it is clear that speed is 20 meter per second throughout journey. As object speed remains constant throughout, it means that object is covering equal distance in equal interval of time throughout journey. So the answer for this question is object is in uniform motion. Question number 4, what is the quantity which is measured by the area occupied below the velocity time graph? So answer is the quantity measured by the area under velocity time graph is displacement. Now let's see question based on equation of motion. तो ये तीन इक्वेशन है मोशन की and are applicable only when object is at uniform acceleration. U is initial velocity, V is final velocity, A is uniform acceleration, T is time taken, S is distance or displacement. Distance and displacement are equal in case of uniform acceleration because object is moving in straight line. Distance or displacement is equal to area under VT graph. Page number 82 in text question, a bus starting from rest moves with a uniform acceleration of 0.1 meter per second square for 2 minutes. Find the speed acquired and the distance traveled. Now what is given here, a bus starting from rest means initial velocity is 0 meter per second. Acceleration is given 0.1 meter per second square. Time is 2 minutes. You need to find speed acquired. Speed acquired means final velocity after 2 minutes and the distance traveled. So distance traveled in 2 minutes. Convert 2 minutes to seconds, that is 2 into 60, 120 seconds. To find V, we can use first formula, that is V equals to U plus AT, as U, A and T everything is given. So from there we'll get V. So we have V equals to U plus AT, U is 0 and A is 0.1, T is 120. So from there we'll get V as 12 meter per second. Now for distance we can use formula UT plus half AT square. So substitute values of U, T, A and T square. So U is 0, so 0 into 120 will become 0. Half into 0.1 into 120 into 120. You can cut 2 and 120. And when you solve, you'll get 720 meters. Some students find it difficult to calculate. So for them, 0.1 we can write 1 by 10 into 7200. So 10 will go. So we are left with 720 meters. Question number 2. A train is traveling at a speed of 90 kilometers per hour. Brakes are applied so as to produce a uniform acceleration of 0.5 meter per second square. Find how far the train will go before it is brought to rest. Now it's given that a train is traveling at a speed of 90 kilometers per hour, means initial speed is 90 kilometers per hour. Brakes are applied so as to produce a uniform acceleration of minus 0.5 meter per second square. So acceleration is minus 0.5 meter per second square. Why minus? Because brakes are applied. Whenever brakes are applied, velocity reduces. Whenever there is decrease in velocity, acceleration is negative. In this case they have given negative sign, but in many questions they will not give you negative sign. That you have to put yourself, because brake is applied so velocity is decreasing. So it's understood you have to take acceleration with negative sign. Now in this case you need to find how far the train will go before it is brought to rest. So how far train will go means you need to find distance s before it is brought to rest, means final velocity is 0 because it is brought to rest. Now initial velocity is given in kilometers per hour, so multiply 90 with 5 by 18 to convert that into meter per second. 18 and 90 will go, 18 you can cut it by 9, 9 2s are, then 9 10s are, then 2 1s are, 2 5 are 10. So 5 5s are 25 meter per second is initial velocity. Acceleration is given minus 0.5 meter per second square. Train is brought to rest. Final velocity is 0 meter per second. We need to find distance or displacement. Now UAV is given, so we can use 2AS equals to V square minus U square to find distance. So substitute in formula. 2AS equals to V square minus U square. So 2 into minus 0.5 into S equals to 0 square minus 25 square. 2 into minus 0.5 is minus 1. Minus 1 into S is minus 625. Minus sign will go. So distance or S equals to 625 meter. Question number 3. A trolley while going down an inclined plane has an acceleration of 2 cm per second square. So acceleration is given 2 cm per second square. What will be its velocity 3 seconds after the start? So time is 3 seconds. Now 3 seconds after the start means initial velocity of trolley is 0 and we need to find final velocity after 3 seconds. To find final velocity, we can use V equals to U plus AT, as U, A and T everything is given. So V is U plus AT, so U is 0, so 0 plus 2, A is 2 and T is 3, so 2 into 3 is 6. So V is 6 centimeter per second. Now in this case answer is coming in centimeter per second because acceleration is in centimeter per second square. So this final velocity will come in centimeter per second. Question number 4. A racing car has a uniform acceleration of 4 meter per second square. What distance will it cover in 10 seconds after start? So acceleration is given 4 meter per second square. Time is given 10 seconds. We need to find distance it will cover in 10 seconds after start. So again after start will give you hint that initial velocity is 0. So U is 0 meter per second. Now we know U, A and T. So we can use second formula to find distance. So substitute in the formula. S equals to ut plus half at square. So S equals to 0 into 10 plus half into 4 into 10 into 10. After solving we'll get 200 meters. So distance is 200 meters. Next question. A stone is thrown in vertically upward direction with a velocity of 5 meter per second. So initial velocity is 5 meter per second. If the acceleration of stone during the motion is 10 meter per second square in the downward direction. Now in this case acceleration is minus 10 meter per second square. Why minus 10 meter per second square? Because when we throw anything in upward direction, its velocity goes on decreasing. At highest point its velocity becomes 0 and then the object starts coming down. What will be the height attained by the stone and how much time will it take to reach there? So we have initial velocity 5 meter per second. Stone goes up with reducing velocity. At highest point its velocity is 0 meter per second. So what we need to find this height and how much time it will take to reach that height where velocity becomes 0 and after that stone will start coming down. So in such question where object is thrown in upward direction, always take final velocity 0 and acceleration with negative sign. We have UAV, we need to find distance S. So we can use formula 2AS equals to V square minus U square. So we'll get minus 20S equals to minus 25. So distance S equals to minus 25 by minus 20, that is 5 by 4 or 1.25 meters. To find t, use formula v equals to u plus at. To make calculation easy, write u plus at on left hand side, that is equal to v. Now take u on right hand side, so it will become v minus u. So from there you will get t equals to v minus u by a. Substitute values, so we'll get t equals to 0 minus 5 divided by minus 10, which is equal to minus 5 by minus 10. Therefore time equals to half second. Question number 7. A ball is gently dropped from a height of 20 meter. If its velocity increases uniformly at the rate of 10 meter per second square, with what velocity will it strike the ground? After what time will it strike the ground? Now this question is just opposite of previous question. In previous question, object was thrown in upward direction, while in this question, object is dropped in downward direction. So whenever object is dropped from height, its initial velocity is always 0. Acceleration is positive because velocity is increasing. In this question, we need to find final velocity of the ball just before hitting the ground and time taken for the ball to reach the ground. Now to find v, we can use formula 2as equals to v square minus u square. To make calculation easy, just rearrange the formula. So we'll get v square minus u square equals to 2as. Now v square minus 0 square equals to 2 into 10 into 20. So we'll get v square equals to 2 into 10 into 20. So multiply 2 and 10, you will get 20 into 20. So why I am doing like this? Because we have v square equals to. So what is v equals to? Root of 20 into 20. So this will make your calculation further easy. Root of 20 into 20 is 20 meter per second is the answer. To find time, use first formula v equals to u plus at. Now rearrange this formula just to make the calculation easy. U plus at equals to v. Take u that side, v minus u, then at equals to v minus u. So from there you can find t. So a is 10, 10 into t equals to 20. So time equals to 20 by 10, that is 2 seconds. Question number 4. A motorboat starting from rest on a lake accelerate in a straight line. Now starting from rest means initial velocity is 0. Accelerate in straight line at a constant rate of 3 meter per second square. So acceleration is 3 meter per second square. Sometimes student may get confused whether this 3 meter per second square is velocity or acceleration. So always remember acceleration unit is meter per second square. So just see if it is meter per second square means that is acceleration. Speed or velocity is in meter per second. Time is given 8 seconds and we need to find distance traveled by the boat. Here u, a and t is given, so use formula s equals to ut plus half at square. So from there we'll get s equals to 0 into 8 plus half into 3 into 8 into 8. So 0 into 8 is 0 and half into 3 into 8 into 8, you can cut 2 and 8. So you are left with 3 into 4 into 8. So 12 into 8 is 96 meters. So distance is 96 meters. Thanks for watching. Please like, subscribe and share.